Hey team, it's Mr. Z, and we're going to continue to practice with quadratic word problems. Let's go ahead and dive in and use area to help us out. All right, when we're doing this, it always helps to first label our diagram. Now, in this, everything is labeled nicely, but it's always important to understand what our variable actually means. So, it has a width of 5x and a height of 3x, where x is going to be feet. 2 feet of material on each side is shown as on the sides. Okay. Define a function to represent the area of the shaded space. So essentially what I need to do is I need to find the base of the shaded region. I need to only find this part. To do so, I'm going to use the fact that from this section in this section is also 2 because it's a rectangle. So from here to here is 2. Here to here is 2. Whatever is left over would be 5x minus 2, which is the same thing as saying 5x minus 4. All I did was combine like terms. That is the base of this rectangle. What is the height of this rectangle? Well, it's going to be 3x because opposite sides of a rectangle are congruent. This is going to be equal to 3x. So, to find the area of the shaded space, I'm going to go ahead and remember that the area of a rectangle is going to be equal to length times width. To turn it into a function, I'm going to use the area of x. This is going to be what is the length, what is the bottom. It is going to be, in a grouping symbol, 5x minus 4. What is the width? 3x. Now, this is technically done, but to derive more meaning, I am going to distribute 3x to both terms. So my final answer, after I clean it up, is going to result in 15x squared minus 12x. In this case, c is 0. You don't need to put it. You can exclude it. I know that this graph is going to be concave up with a y-intercept of 0, 0. What is the area that the shaded space can be if the width of the shaded region is 11? So, to make sure I'm using the same wording as the problem, I'm going to go back to the original problem. The width of the shaded region is 11 feet. The width is 5x. So, the shaded region is going to be this blue spot. It is not just 5x. The shaded region, this is the whole diagram. So, let's go ahead and see if this works. The shaded region is 11 feet. So, what I'm going to do is I'm going to let 5x minus 4, the width of the shaded region, be equal to 11. I'm going to use inverse operations. I'm going to result in 5x equals 15. And after I divide each side by 5, it's going to be x is 3. So this is not the area. This is a component in which I need to find my area. So using my given, I was able to find 11. Now I need to plug this in. I need to make it a, but this time I need to solve it for 3. So a, 3, it's going to be equal to 15 times 3 squared minus 12 times 3. Go ahead and use order of operations to clean this up. 15 times 9 minus 36 15 times 10 is 150. So 15 less than that is going to be 135 minus 36. 35 minus 35 is 100. So we'll take away one more, and I'm going to get that the area of the region is 99. This is going to be the area of the shaded region. Notice, find your area formula, figure out what you're going to use for x, and then plug it in. In this situation, Franco is parting part of a wall gray as shown in the diagram. It has a width of 4x and a height of 2x, where x is feet. 1 foot of rectangular spaces will be left white as shown. So these spaces are going to be 1, 1. This looks to be 1. Let me change color. But we actually don't know what the value of this is. It might be close to 1, but we can't assume it's going to be 1. So we need to find the area of the shaded space, which is 2 regions. So in order to do this, what we're going to do is we're going to find the area of the entire rectangle and then we're going to subtract the area of the white space, the area of the white. We're going to take away the last area of the white. Since all 3 of those particular white rectangles are congruent, I can think of what I need to do is take the area of the total, and I'm going to subtract 3 times the area of the white. Now this isn't a formula yet, but this framing is going to help me generate my equation. So let me go ahead and find out what is the area of the entire rectangle. Well, the area of the entire rectangle is going to be length times width. So this first part, the area of this shape is going to be 4x times 2x minus 3 rectangles. Well, the area of each of these is going to be length times width. 1 times 2x is 2x. 1 times 2x. And then this is also 2x because opposite sides of rectangles are congruent. So the area of my rectangle can be represented by 1 times 2x. I clean this up. Now I'm going to go ahead and combine like terms, revealing 8x squared minus 6x.